Welcome back to the channel, guys. Hope you are doing extremely well, and this is your very own Mascota this side. So welcome to the lecture number 31 of the linked list series, and hopefully this will be the last lecture of the linked list, right? But don't worry, I will be uploading the practice questions daily into the playlist, so you will never get out of the practice and your concepts will remain sharp, right? Now the problem is clone linked list with random pointer, right? So you can see that there is a linked list, but the linked list is actually very different from the previous ones. You can see that there is a next pointer as usual. This somewhat pink color shows the next pointer, right? But there is also some green pointers, right? The pointers marked in green. What are these? So there are two pointers. Usually there are two values in the linked list node. One is data and another one is next. But the question says that there is one another value that is random. That is random, right? And now you can see, so green points mark the random. So random can be anywhere, like one's random is 7, 13's random is 7, 10's random is 11, 11's random is 1, and 7's random is null. Null can also be a random pointer. Now your task is, the question expects you to make a perfect copy of this linked list. Make a perfect copy. Make a perfect copy. That is the meaning of clone, right? Make a perfect copy, right? That is, you cannot return the same linked list. You have to create new nodes. That is something like this. Your new linked list will look something like 7, 13, 11, 10, 1. Next pointers will be exactly same like this, and the random pointers will also be exactly same. 13 to 7 and 7 to null, right? And 11 to 10, 11 to 1, sorry, 10 to 10 to 11, and 1 to 7. This will be your exact answer. This will be your answer, right? You can see the both the linked lists are actually same, but the memory address is, suppose this is memory address 1, 2, 3, 4, 5. So this will be anything random, like suppose A, B, C, D, E. These memory address will not be equal to this. The memory address is different, but they're depicting the same linked list, right? So I hope you're clear with it. The input is a linked list and the output is a exactly same linked list, right? But the nodes are on the different values. Also, you cannot change its structure. You cannot change this structure. This structure should also remain same. Should also be same. You cannot change the structure. At the end of the algorithm, this structure should be conserved and this structure should be made. Now, how will you solve the problem? How will you solve the problem? So my first approach is, so my brute force approach, let me mention it, my brute force approach. I have to deep copy it. Okay, I will deep copy it. I will create the new node 7, 13, 11, 10, 1. So what will I do? I will use a loop. I will say my temp equals to my head, right? Now, while while temp is not null, what will you do? First of all, make a dummy node, right? Make a dummy node. Let us say you made a dummy node with value -1. You assign a to dummy node. Then for every temp you created a new node. Let us say insert, let us say this a new node is named insert, new node with the value of temp value, and then a next equals to insert, and then a equals to a next for the further insertion. So on the given linked list, that is on this linked list, what will the loop give me? The loop will provide me with a structure something like this: 7, 13, 11, 10, 1. You can see I have not marked the random pointer side. Now this loop is only giving me the basic structure. These are the nodes. I have not marked the random pointer side now. Now what will happen? So I have to mark the random pointers as well because I want the deep copy of it. So I want the random pointers as well. So what will I do? Let me copy the linked list downwards. This is my linked list. I want to make this linked list same as this one. Now what will happen? I will see 7. Suppose for the random pointers I do something like this. I will keep temp here and I will keep a here. Now what will happen? What will happen? Now I will just do something like this. For 7, I will see what is the 7's random pointer. 7's random pointer is actually marking to the null. So what will I do? I will just do the same. So I will just do 7's is pointing to null, right? This is my random pointer. Then moving 13, that is a will come here, temp will come here. Now here temp's random is 7, so a's temp is also going to be 7. Now the problem is It is not an array. In an array, I can use the indexes to traverse in the O of one time, right? In an array, I can use a index to traverse O of one time, but it is not an array. So what can we do? What can we do? I can use the traversal again. That is for each A, that is my A is here. I will find this value. I will find this value and then I will traverse the whole linked list whenever this node and this node are actually same. This 7 is actually corresponding to this 7. I will attach it, right? So I will be traversing the whole linked list again and again to mark pointer of each node, right? But that would be not optimal, right? Why? Because for n nodes I will have to traverse n times, that is O of n into n, giving me a time complexity of O of n square, right? Can I optimize it? Yes, I can optimize it. How? What I'm saying is, let me maintain a data structure. Let us take a map, right? Because map helps us to define a relation between two values. So let us take a map. So at the time of forming the nodes, what will I do? For this 7, I will correspond this 7. Suppose this address is A, this address is X, this B, Y, C, Z, D, W, and E, let us say B. Let us say W, X, Y, Z. Let us say F, right? Let us say F. Now what will I do? At the time of forming the nodes, at the time of forming the basic node, that is 7, 13, 11, 10, 11, what will I do? I will insert them into the map. That is, this A is actually marking to X. This B is actually marking to Y. C is actually marking to Z. And similarly, D is marking to W and E is marking to F. Right? This will be keeping in my map data structure. Now what will happen? Temp will give me random pointer A. Right? So temp gave me the random pointer. Temp random equals to A. From this A, using this map, I will get X. And now what can I do? I can say, suppose my this pointer is temp2, right? 13 pointer is temp2. Temp to random, sorry, equals to X. What did I say? I just mapped the data structure, that is A is corresponding to X, B is corresponding to Y, C is corresponding to Z, D is corresponding to W, E is corresponding to F. And now what will you do? From the temp random you will get A. From A, using the map, you will get X, and from X you can just do temp to random equals to X, and in that way you are joining the two nodes in O of one time. But the space complexity now, guys, is O of n. It is increased by O of n because I'm maintaining a data structure of map, right? Okay, so what is my algorithm? By optimal, like not my optimal but my efficient algorithm looking like. So first I created a linked list, the template data structure, something like this. So dummy equals to new node with -1, A equals to dummy. Then you created a map which is marking nodes star with node star, right? Let us name it as MP. Now what will happen? Temp is starting with head while my temp is not null. What will you do? You will first create a new node. So let us say my new node is named as X equals to new node with the same value of temp value. Now what will you do? You will say that A next equals to X, A equals to A next. Now insert into the map. So MP of temp equals to X. And now you can just move temp equals to temp next. This will give you the basic data structure. This will skeletal is formed and the map is formed. But from the skeletal you will have to remove the dummy node as well. So let us do that. So I will say let us name it as nh equals to dummy next, and then you can just delete dummy to free the space. So delete dummy. Right now you have something got like this. You have this skeletal and this in hand with the data structure map. Now it is simple. Now what will I do? I will keep a pointer temp1 at the original head, temp2 at my new head, while temp. You just have to assign the random pointers, right? Okay. So let us say my node equals to temp temp1 random, the original random, right? Okay, now what will you do? You will do, if my node is not equals to null, if it is equals to null, remain it, because temp2 is also temp2 random is also at null only, right? Okay, if it is not null, then a equals to mp of node, get the value from the data structure to which I have to join, and now temp2 random equals to a, and now you can just close the if condition and you can now traverse. So it was while temp1 here, so temp1 equals to temp1 next, and temp2 equals to temp2 next, right? This will give me the correct data structure, and I can simply return nh. What is the time complexity, guys? What is the time complexity? So I'm actually traversing it once for the formation of the skeletal, then I am actually traversing again for the formation of random pointer. So O of n for uh, that one, and O of n for that one, so O of 2n, right? Plus I am actually using the map, so it is n log n, actually n log n, so it is O of n log n. This is my time complexity, and my space complexity is O of 2n. Why 2n? N is for the map data structure and n is for the new nodes, right? So O of 2n, actually going to O of n only. O of n log n is my time complexity, O of n is my space complexity. What if I say that I have a better space complexity and time complexity for you? That is, I will be trying to do it in O of n with O of 1. Will you be amazed? Will you be amazed with that? Will you be amazed? I hope so. Let us move to that approach. Let us move to that approach. How? So this is my linked list. Now I just have to conserve this one. The structure should remain same, and I have to make a deep copy of it, right? But I am saying that I will try something new. I will just change the structure of it, and then I will go to the original one. That is, I will change the structure. First is change the structure, and the second one is go back to original structure. Go back to original structure. How? So I am changing the structure, that should be of my use. So what I am doing is I am actually creating a new linked list, something like this: 7 from the original, 13 from the original, 11 from the original, 10 from the original, 1 from the original. These are the original nodes. My new nodes are exactly same. That is, I will insert 7 here, 13 here, 11 here, 10 here, 1 here, right? I just inserted new nodes. Let me mark it down. This is for new, and this is for this is for old, and this is for new. That is, I will just replicate the nodes and I will attach to them. It is very easy, right? I will have to insert 7 after 7, 13 after 13, 11 after 11, 10 after 10, 11 after 1, right? Nothing too complicated. Now what will I do? The current pointers are something like this. 7 is actually pointing towards null, so I'm actually doing something like this only. 7 is actually pointing towards null. 13 is pointing towards 7. 13 is pointing towards 7. 11 is pointing towards 1, right? 11 is pointing towards null. 10 is pointing towards 11, right? I have not made the next node right now, and 1 is pointing towards 7. So 1 is something like this, right? 1 is pointing towards 7. Now my new next are something like this. My next are something looking like this, right? I have lost the count of previous next. My next are this, right? What can I do? I will just start traversal in this linked list. I will just start traversal in this linked list, something like this. I will keep a temp here, right? So I will say while temp, my temp is currently at 7. Now what will I do? I will say new node is equals to temp next, right? If my temp is here, the exact replicated node of 7 is this, that is nn. Now what can I say? I will say ra is equals to temp random, right? Temp random. So initially for 7 it is null, right? So what will I say? If ra is equals to null, do nothing, because its random is also initially assigned to the null because of the constructor. You can just, for the safety, you can say new nodes random equals to null, right? In the else condition, right? For the case when my temp is at 13 and my nn is at 11 13, right? Okay, now what will happen here? So you can see that the random pointer of this node is actually pointing to 7, and I want to make the random pointer of this node actually point to this one. That is, temp and new node have a distance of 1, random and new random have a distance of 1, right? So what will I do? I will just use that to my advantage. Else what will I do? New nodes random is gonna be equals to ra next. You can see if my new node is at 13, then ra is here and ra next is 7. I will just join something like this, and that is what I wanted. I wanted to join this 13 with this 7. That will happen, right? That will happen after the else, if and else condition. I will just move temp. Now temp was initially here. In the next condition, temp should come here. That is, temp is going towards next of next. Temp is going towards next of next. So temp equals to temp next next, right? This link, this what do we say? This step will give me something like this. 13 will be joined to 13. 7 will be joined to null. This 11 will be joined to this one. That is something like this. And this 10 will be joined to this 11. And 1 will be joined to this 1 will be joined to this 7, something like this, right? Okay, so this is my, now I am standing at this position. I have joined, like, what I have accomplished? I have successfully joined random, but seriously a crucial step is left. What? This was my original linked list. I will have to separate the original with the new. I will have to separate the original with the new, or you can say the duplicate as well. So 7, 13, 11, 10, 11, all the nodes in blue have to be written separately. What can I do now? What can I do? I will just do the basic 30 lecture which I have done, only that step only. What will I do? I will create a new dummy node. I will create a new dummy node here, right? Suppose I create a dummy node -1 here. What will happen? I will keep a previous pointer at my original head. That is my original, this head. Now what will happen? If previous, like the node, if previous is not null, that means the next pointer is also not null. What will happen? My dummy is here, my a is here. I will say my temp is previous next. I will keep my temp here. I will keep my temp next equals to temp next. Now what will happen? -1a next is equals to temp, right? So that will be equals to 7. And after that, previous next equals to next. That will, I will break this connection and I will form something like this, right? So my loop is looking something like this. So I will keep previous at head, dummy equals to new node with -1 value, and a equals to dummy. Now what will happen? While previous is not null, temp equals to previous next, and then just the simple steps. A is next is equals to temp. Now I am saying next is equals to temp next also. Next equals to temp next. A is next equals to temp, and now previous next is equals to next. Previous next is equals to next, right? And also a equals to a next for the further insertions. A equals to a next, right? Previous next equals to next. Also traverse it. So previous equals to previous next, right? This will give me the original linked list, but the new linked list will have a dummy node. So delete dummy will be the same operation we have been doing many times. I will not be repeating that. I will just write down into the code, right? So hope you were able to understand it. And you can see I stick by my words. I just created a skeletal first, so that gave me O of n time complexity, and then for one more time of the traversal, I just use O of n plus n for the time complexity. And the space complexity I use is actually O of n for the new nodes. That was to be used anyway, so it is actually evidently O of 1 only, right? So I was sticking by my word and I have provided with the optimized approach. That deserves a like, right? Okay, now it is time for us to see the code, right? Alright guys, so here is the coding section. Hope you are all excited for the last lecture of the linked list series. Okay, but I will be uploading the new content as soon as possible, right? The new practice question should to keep your pointer, to keep your memory sharp, right? So okay, moving on. If my head is equals to null, that means I can simply return the null position right now. If you have not provided me with something, what do I copy, right? What do I copy? Moving on, node star temp equals to head, while my temp is not null, what will you do? You will insert the new value. So node star insert equals to new node temp value. The new node name is insert. Temp next equals temp insert next equals to, it will be insert next equals to the original temp next, and then you will change the temp next. That is temp next is equals to insert, and then for the traversal temp equals to insert next, temp equals to insert next. Now what will happen after this? Nothing to do, nothing to worry. Node star previous is equals to head, node star previous equals to head. Now what will you do? While my previous is not empty, while my previous is not null, I will say temp equals to previous next. That is, I have to join the random pointers, right? This is for joining the random pointers. If my previous pointer has a random, if my previous pointer has a random, then temp random will be equals to previous random next, previous random next. Right? What will happen after that? I will have to move my previous, that is prev will now become equals to temp next. Right? Is I have to skip two nodes, right? So temp was already previous next, now previous will be equal to temp next for the further iteration. Right? Okay, so I have made the skeletal, I have joined the random pointers. Now what will happen? I will have to separate the linked list. So temp equals to head right now, temp equals to head, and now I will just create a dummy node, node star dummy equals to new node with value -1, and node star a equals to dummy, currently pointing to dummy, right? And instead of temp, let me name it as previous, that will be easier to understand, right? While my previous is not null, while my previous is not null, what will you do? You will just separate them, that is temp will be equals to previous next, right? A next will be equals to temp, a will now become equals to a next, and now my node star next will be equals to temp next, that is the original node in the, that is actually the previous next. Then what will you do? You will just connect the nodes. So previous next is equals to next, previous next is equals to next, and move the pointer, that is previous equals to next, previous will now become equals to next. In the answer node you can just create node star answer equals to dummy next, and then delete the dummy, delete the dummy, and then return the answer. So return answer. Let us try to compile and run it. Hope it will work fine. Should not give any error, I guess. It is getting accepted. Let us try to submit as well. Should run fine, I guess, and it is running. Okay, it is getting accepted. So thank you for watching, and we'll meet again tomorrow with the new practice question set, and the series will continue, right? Because I want you to be the best. Okay. So thank you for watching, and we'll meet as soon as possible. Thank you. Have a nice day. And also do not forget to subscribe, please. It really motivates me, right? I've actually completed the whole linked list series, so I think that means a real good subscription. Thank you. Have a nice day.